Hi and welcome to video 3 on this matrices and solving systems of linear equations using matrices, Specialist Maths Unit 3, Topic 2, which is vectors and matrices. And in this video we're going to move on from the 2x2 matrices from the last video and talk about n by n matrices or n by n systems of linear equations. What I mean by n systems of linear equations is when instead of a 2x2 where something like maybe x plus 2y equals 7 and 2x minus y equals 12, well now we have 3x3, so maybe we've got a plus z there and a minus z there, and then y plus z equals 4 or something like that. So we've got three matrices or three equations and three variables, and that's what it would look like. That's a 3x3, of course, and it goes on. So for solved applications we work only with square matrices, remember? The number of relationships to the number of variables, and we have to add rows of 0. So if we didn't have this, we would have 1, 2, 1. This is our x, so x is our coefficient matrix. 2, -1, -1. But then we'd have to add a 0, 0, 0 to make it a 3x3 matrix. Otherwise it doesn't really make sense. This is going to be a problem anyway in a lot of cases, so you won't see this often. For 3x3 or greater, we use technology. So it's really important to note here that the syllabus states 2x2 matrices, you will be required to find the determinant in some cases, whereas the 3x3 or greater, you are allowed to use technology in all cases. So you won't get a 3x3 in a tech-free paper. So let's have a look at example 2. Calculate AB where A and B equal this. So we're going to practice our multiplication and then hence determine A inverse. So this is interesting, and I suspect I know where this is going. I can't remember this example, but AB is equal to 2, 1, 0, -1, -3, 2, 0, 1, 3, times 11, 3, -2, -3, -6, 4, 1, 2, 5, and this is equal to, so we get, remember we're doing first row by first column. So I'm actually going to do the calculation. 2 by 11 is 22, minus 3 plus 0, so that's 19. And then 2 by 3, I'm doing first row, second column. 2 by 3 is 6, minus 6, that's 0. And then 2 by -2 is -4, plus 4, that's 0. So I get 19, 0, 0. And then I've got -1 by 11 is -11, plus 9 plus 2 is 0. And then I've got -1 by 3 is -3, minus 18 makes -21. Hold on, -3, so plus 18 makes 15, and then plus 4 makes 19. And then -1 times -2 is 2, minus 12, so that makes -10, plus 10 is 0. I can see where this is going. 0 times 11, -3 plus 3 is 0. 0 times 3, I don't have to worry about the 0 anymore, so I just get -6 plus 6 is 0. And then I get 4 plus 15 is 19. So AB is equal to that, which of course is equal to 19 times I. Well, that means that if A inverse equals I and AB equals 19I, I can pretty well deduct that A inverse equals 1/19 of B. And so I could just stick a 1/19 in front of there, and that is my A inverse value. And it's come from the fact that I recognise this as I. There's a few questions poking around like that. So keep in mind with these determinants of 3x3s, which you can do on calculator, you could legitimately get a question like this in a tech-free paper. But they're going to give you enough information to work it out. You're not expected to know how to do a determinant for 3x3. Maybe you can explore that if you want to, though. It's not that hard. So there's exercise 7D, and I encourage you to jump in and have a go at those. All the best.